So here I've written a little Python script which randomly produces solutions to adding any two random numbers together to be any other random number. So, for instance, let's run it here. So we're going to add two values together and get a third value out. And our two values that we're adding together can be anything. I like prime numbers because it ends up being more of a pain in the ass if you were trying to do this manually. So let's go ahead and use prime numbers. So we're going to add 19 and 23 and get out 7, right? So 19 plus 23 equals 7. And this is going to give us 20 solutions, which are all true. There you go. So 19 divided by negative 23,112 plus 23 divided by 34,155 is 7 on negative 47,080. Right? So here the unit of the 7 is per negative 47,080. The unit on the 23 is per 34,155. Right? And when you think about this, any unit conversion, you're going to have a ratio like this. You're going to have a relationship, right? It's going to be per something. Okay? So this is all we're doing is we're discovering possible ways to do that. And the thing that I'm intending to illustrate here is there is an absolute infinitude of these, right? So there isn't a cardinal sequence to the numbers, right? You would think, because 19 and 23 are larger than 7, when you add them together, you can't get 7. But that's absolutely false. All of these will work. Every single one of these will work. And these input values that it's taking, they can be any number. Right? These 3 that I'm giving it can be any number. And the 2 that it's randomizing can be any number. And then that third one is also going to, as long as these are all integers, that third one that it's producing is also going to be an integer. One thing to note about this, however, though, is the denominator on your second number, on y, because b is the denominator for y, a is the denominator for x, b for y, c for z. That's the way that I set this up. Alright, so x is divided by a, y is divided by b. If you notice, b has y in it as a factor, so this is never reduced. So there's even more solutions than this can produce for you. So it's even a larger infinity of possible ways to do this than what this algorithm is capable of. But this is already capable of producing a countable infinity of solutions, which I feel like that's, as far as a nice reference point, I feel like that's pretty solid. It's pretty solid. So, yeah. Let's run it again with some different values, just so you can see it. So, see 3 integers, 217, 6, and when we add those together, let's get 5. It does have some biases, as you might notice. So these are all per negative unit. It doesn't necessarily have to work out that way. So again, there are some biases in this algorithm, but it works. So there you go.